All right, so one of the last things that I wanted to show you in this section is how to find and how to compute these inverses using your graphing calculator. So in one of the videos, we focused on finding the inverse of this matrix right here. So let me just show you how to double check that using your graphing calculator. So I have my calculator pulled up here. Let me adjust the size of it so we can see both of these things at the same time. Okay, so the very first thing that we need to do is we need to input this matrix here. So I go to Second Matrix, over to Edit, and you can input it into any matrix that you want. If you like to keep it consistent with A, that's perfectly fine. I'll do the same thing. Now, I already have a matrix edited in here, but I'm basically going to overwrite that matrix. So my new matrix A is a 2 by 2. My entries are 2, 1, 0, and 1. So I have matrix A now inputted the way that I want to. And if I want to find the inverse of matrix A, I go back to my main screen by quitting. I select matrix A by going back into matrix and just selecting matrix A. If I want to find the inverse, then I very easily just push the inverse button. And so when I do that, that gives me this right here. Notice it's going to give the answers as decimals. You can actually very easily convert this to fraction using the fraction key that we've done so many times before. So math is going to change my last answer into a fraction, as it just says. And so now it gives me my matrix in fraction format. So if I compare this with the answer that I got, which was this guy up over here, we can see that we did compute our inverse correctly. Now, when I tried to compute the inverse of this, it didn't work out. So let's see what the calculator would do if we try and do this. So I'm going to input in matrix B, so second matrix, edit, down to matrix B. Again, I'm overwriting whatever I had previously, no big deal. My entries were 0, 1, 0, 0. If I want to find B inverse, I just pull up matrix B, and I push my inverse button. Now, we know that there wasn't an inverse. We could not row reduce this, so let's see what the calculator tells us in that case. And it tells us this here. No inverse matrix exists. There's an error, okay? So we can either quit or go to. It doesn't really matter in this. I'm just going to quit because I know that's the true case. We did a couple more examples, so let's double check these here. So this example here gave us this matrix A, so let's input that in. So second matrix, over to edit. This one was also a 2 by 2, and so our entries were 4, 2, 3, 1. So if we go to pull up matrix A and then the inverse, notice again it gives us decimals, so let's convert it to fractions. We get the answer of this right here, and that's what we had down here. -1/2, 1, 3/2, and -2. Okay, I also had a 3-dimensional example where we got this inverse down there. Let's make the calculator double check this one for us. Inputting it again in A, this one was a 3 by 3. My entries were 1, 2, -1, 3, 5, 3, 2, 4, 3. So we're going to go back to the main screen by quitting. We're going to pull up our matrix A, and we're going to hit the inverse button. We do know that our answer is going to be in fractions, so we might as well go ahead and this step tell our calculator to convert it in the fraction mode. So you don't have to do it as a 2-step sequence in your calculator. And we get this answer here. So let's see how that compares with the answer that we got down here. see if I can get both of these on the screen at the same time. Yes. So we can see that we have gotten the correct answer along the way. Okay, in the last video we used those inverse matrices to solve a system of equations. My specific example was this here. We have our matrices over here. So I'm going to show you how to double check either this full thing or double check it step by step along the way. Of course, we know how to double check to confirm that we've just got our A inverse correct. So let me go back in and change my A matrix one more time to show these coefficients over here. 4, 2, -1, 9, 0, 1, 4, 5, -2. So if I just want to check that I've got my inverse correct, I'm going to do the same sequence as I did last time. A inverse, and I'm going to convert it to a fraction because I know I got lots of fractions in that one. Gives me this down here, so let's compare that with the answer that we got down here. Lots of colors happening, but let me see if I can get rid of those, and we can see that we got the correct inverse there. So as you can see that every entry here matches every entry over there. Now really what we wanted to do is we wanted to compute the sequence of A inverse times B. So we can do this as 2 steps on our calculator. We've already computed A inverse. We can just take that answer and we can multiply it by B. But first I need to enter in that matrix B. So let me go over to edit. Matrix B was a column matrix 3 by 1 with 3 by 1. Okay, so if I go back to my main screen, now I'm just going to take the answer that we just got, which was A inverse, and multiply it by matrix B. And so when I get that, I get this answer here, which is the answer that we should have got as this system of equations, where our x value was equal to 6/7, our y value was equal to a -11/7, or a z value is equal to -19/7. Now, if you don't care to check what the A inverse matrix was, you can actually input this as one key sequence in the calculator. You can just say, hey, take my A, invert it, and multiply it by my B matrix. And of course, we want to convert it into a fraction. So we don't have to do that 2-step sequence in the calculator. We can write it just exactly how it is. Of course, it should give us the same answer because we're doing the same computation. So you can double check any of your inverses or double checking by solving any system of equations using this method very easily using your graphing calculator. All you need to know is how to use those matrix features and the specific operations for each. And so that's where this section ends up.